We're going to do a basic cylinder application here. We have a cylinder mounted at 60 degrees from the horizontal, and it's required to lift a load of 15,000 pounds. We want to find what's the force the cylinder needs to generate. Okay, so this is our force of our cylinder over here. Okay, so that's our force of our cylinder. First thing we need to do is find angle A. So we say angle A. Okay. Well, we have to remember that all the angles in a triangle add up to 180 degrees. So angle A is going to be 180 degrees minus 90 degrees minus 60 degrees, which is 30 degrees. So angle A over here is 30 degrees. Now we have to find the bearing force and the cylinder force. So what we need to do is the bearing force is always perpendicular to the cylinder force. So if I come off the cylinder here at a 90-degree angle. Alright, so let's mark this as 90 degrees right here. So I'm coming off the cylinder at 90 degrees. Okay, so this is now the force of the load here, and this is the bearing force. So now we want to be able to calculate the cylinder force. Okay? Well, we know our relationships here. So if we know this force here is 15,000 pounds, okay, I know that the trigonometry that we went over, alright, to find the cylinder force, we need to use cosine, because cosine is adjacent or next to the 30 degrees, and the hypotenuse of the triangle that we drew, not the original triangle, but the triangle we drew is actually our force load, which is 15,000. So that's why you have to be careful. We got to make sure we draw our new triangle and see where exactly our hypotenuse is, and things have changed a little bit. So to write this, I know that I can say cosine of 30 degrees equals adjacent, which is our cylinder force, over our hypotenuse, which is our load force. And this is CYL here if you can't read well. Okay? So right now we are calculating the cylinder force. So we have to solve this algebraically. So we know that our cylinder force is going to be, well, I have to multiply both sides by the force load because they're dividing here. So our cylinder force ends up being our force load times cosine of 30 degrees. Okay? So our force load is 15,000 pounds times cosine of 30. And make sure your calculator is in degree mode when you calculate this, or you're going to end up getting the wrong answer. So our cylinder force is 12,990 pounds. Alright. So that's the cylinder one. Let's go ahead and let's take a look. What if I asked you to find the bearing force? Remember, the bearing is down here. Alright? So that's a different trig relationship. Notice that the bearing force is opposite the 30-degree angle. So since we are opposite, remembering SOHCAHTOA, sine is opposite over hypotenuse when we calculate this out. So if we want to calculate the bearing force, we are going to say sine of 30 degrees equals opposite, so that's our bearing force, I'm going to call FBER, divided by the force of the load. Same math applies that we did in the first problem. Since these are dividing, we're going to multiply both sides by the force of the load to get the force of the bearing by itself. And when we do that, we're going to get the force of the load times sine of 30 degrees. So our force load hasn't changed. It is still 15,000 pounds times sine of 30 degrees. Once again, make sure your calculator's in degree mode. And we roughly get 7,500 pounds. Is our bearing force. So whenever you want to think of it, it's tough in this pictorial, but always think of cosine as a horizontal type vector or quantity, and sine is a vertical type quantity. Alright? So whenever we're calculating the cylinder force, okay, we're most likely always going to end up using cosine because we want to use this angle here that actually touches the force that we're looking for.